Hello everyone, welcome to the electromagnetic theory and interference course. In this session, we will solve a problem based on lossy dielectric material. So the given question, a lossy dielectric has an intrinsic impedance is given for the lossy dielectric, that is eta value, and uh, they have given the wave is propagating to a dielectric and has the magnetic field component. Magnetic field component is given, that is h equal to h naught e power minus alpha x cos of omega t minus beta x into the unit vector. By seeing the unit vector, we can see magnetic field is along the y direction. Ampere per meter is given. We are asked to find the electric field and the attenuation constant alpha. So to find the electric field, we should know in which direction it is propagating electric field. So we know that given wave is traveling along positive x-axis because of seeing the negative sign of the beta value, and along with that what component is given, it is along the positive x-axis. So AK is here AX, AH is here along AY. So we already know one expression, that is AK cross AH is equal to minus AE. So AK is AX, AH is AY. If I cross multiply, I will get AZ. Since it is negative here, the direction of the electric field is along the negative Z direction. Right, it is along the negative Z direction. So we can mark that here. It is along the negative direction. Okay. Now let us understand how to find the electric field intensity. So we need the magnitude, right? One direction will be different, magnitude will be different, and there will be a phase shift. That is the difference in both electric and magnetic field equations. So we already know the relation intrinsic impedance is equal to E naught by H naught. So E naught is nothing but H naught is 10 into the 200 into angle 30 degree we have to multiply. So 10 into 200 is 2000. 30 degree I can write as e power j pi by 6. So 180 by 6 is 30. So except for the amplitude and phase difference and also the unit vector E and H has the same form. So we can write electric field as real part of this um, magnitude component. So what is this? It is e power minus alpha, and here inside omega t minus beta, right? So e power minus gamma x I can write commonly, and one phasor term e power j omega t, the unit vector along the electric field component. We can write electric field as the real part of this entire component. I can club it e power j pi by 6 and e power j omega t I can club, and here instead of gamma we have to apply alpha plus j beta. There also one j term is coming. So here e power minus alpha is taken out, and the direction of electric field is along the negative Z direction, right? So AZ is written, the negative side is given before, and instead of 2000 they have taken 2, and they're going to write the unit in kilovolt per meter. So for kilo, the 1000 has taken out. Then what is left over here? J term. So omega t minus, instead of beta it is x by 2 and plus pi by 6. So electric field is leading the magnetic field by the phase angle of 30 degree. To find alpha value, we know the relation between, we know the expressions for alpha and beta, because we already know beta from the given expression, it is 1 by 2. So if you take a ratio, it will be helpful to find alpha. So only we are taking alpha by beta, and we are cancelling the omega mu epsilon by 2 on both sides, and we are left with this term. And how to find this part is because tan 2 theta eta, that is the angle of intrinsic impedance, is equal to tan of 2 into the angle of intrinsic impedance is given as 30 degree. So with that, tan 60 is having the answer of root 3. that answer is going to be equal to sigma by omega epsilon. So if I substitute here in the sigma by omega epsilon as root 3, we have root 3 the whole square. Okay, that is after taking the square it will become 3. 1 plus 3 divided by 1 plus 3. So root of 4 will come on both sides. So root of 4 is 2. So 2 minus 1 divided by 2 plus 1, the whole root. So if I take it is going to be 1 by root of 3. Already we know beta is 1 by 2. If we substitute, we get alpha equal to 1 by 2 into root 3. And the answer is going to be meters per meter. So if I want to convert to decibels, I have to multiply it with 8.686. I hope you understood how to solve a problem given in Lossy dielectric. When magnetic field is given, we can find the other field, and we can find the attenuation constant, because in the expression itself beta is not right, and intrinsic impedance is given to us. Thank you everyone. We will meet next.